Regular. A regular moon forms close to its planet, either from the same disk of material that built the planet itself, or from debris thrown up by a giant impact. Its orbit is prograde, meaning it travels in the same direction as the planet spins. Its inclination is low, and its path is nearly circular. Earth's moon formed from the debris of a Mars-sized body that struck Earth early in solar system history. Jupiter's 4 Galilean moons formed from the disk of gas and rock that surrounded Jupiter as it grew. Regular moons account for nearly all of a planet's total moon mass. Irregular. An irregular moon was not born near its planet. It was captured, a small rocky or icy body that wandered too close and got trapped by the planet's gravity. Its orbit is highly inclined, often tilted more than 90 degrees to the planet's equator, and frequently retrograde. Its path is elongated and far from the planet. Jupiter holds more than 80 irregular moons, most under 10 kilometers across, dark and difficult to detect. They cluster into dynamical families, remnants of larger captured objects that were later shattered by collisions. Shepherd. A shepherd moon keeps a planetary ring from spreading apart. Ring particles naturally drift outward and inward over time, but a moon orbiting just inside or outside a ring edge exerts a gravitational nudge that pushes stray particles back. The result is a sharply defined ring boundary. Prometheus and Pandora flank Saturn's narrow F-ring on either side. Their competing tugs maintain its structure while also producing waves and kinks visible in close flyby images. Co-orbital. A co-orbital moon shares its orbital path with another moon of nearly identical size. The two bodies cannot occupy exactly the same orbit, so they interact. As the trailing moon catches up to the leading moon, they exchange momentum rather than collide, and they swap positions. The trailing moon becomes the leader. This cycle repeats indefinitely. Janus and Epimetheus at Saturn complete this orbital swap roughly every 4 years. Their combined mass is too small to disrupt the exchange, and too large for either to be absorbed by the other. Trojan. A Trojan moon orbits locked to a Lagrange point of a larger moon in the same system. The L4 and L5 Lagrange points sit 60 degrees ahead of and behind the larger moon along its orbital path, and objects there are gravitationally stable. Telesto and Calypso sit at the leading and trailing Lagrange points of Saturn's moon Tethys. Helene and Polydeuces occupy the equivalent points of Dione. Trojan moons remain there indefinitely as long as the gravitational balance holds. Shepherd and Trojan moons are orbital roles, not physical categories. The same moon can play only one role, but its composition can vary. Volcanic. A volcanic moon is heated from the inside, not by radioactive decay alone, but primarily by tidal flexing. As it orbits in an elliptical path, the planet's gravity repeatedly stretches and squeezes the moon's interior. That mechanical energy becomes heat, and that heat drives volcanism. Io orbits Jupiter in resonance with Europa and Ganymede, which keeps its orbit elliptical and the flexing continuous. Its surface is resurfaced constantly by silicate lava flows and sulfur compounds. It has no impact craters. Every crater that forms is buried almost immediately. Ocean. An ocean moon conceals a global liquid water ocean beneath an outer shell of ice. The ocean stays liquid because of tidal heating, radiogenic decay, or both. Europa's ocean is estimated to contain more than twice the water of all Earth's oceans combined, separated from the surface by a shell of ice kilometers to tens of kilometers thick. Enceladus vents its ocean directly into space. Geysers near its south pole spray water ice and organic compounds through cracks in the surface, feeding Saturn's E-ring. Ganymede and Titan may also harbor internal oceans, though their evidence is less direct. Atmosphere. An atmosphere moon retains a substantial gaseous envelope around its surface. Titan is the only confirmed example in the solar system. Its atmosphere is denser than Earth's, composed primarily of nitrogen with methane as a secondary component. Methane cycles through Titan the way water cycles through Earth. It evaporates from lakes near the poles, forms clouds in the troposphere, and falls as rain onto drainage channels that flow into lakes and seas. Triton, Neptune's largest moon, holds a thin nitrogen atmosphere with a surface pressure less than 100,000th of Earth's. It is slowly being stripped away as Triton spirals inward. Inner small. An inner small moon orbits deep within, or just interior, to a planet's ring system. Tidal forces at these distances prevent the moon from pulling itself into a sphere. Ring material accumulates around the moon's equator as particles from nearby rings settle onto its surface, creating distinctive shapes. Atlas, which orbits near the outer edge of Saturn's A ring, has a pronounced equatorial ridge that gives it a flying saucer profile. Pan, embedded in the Encke gap, maintains that gap through its gravitational clearing and carries a similar ridge. Retrograde. A retrograde moon orbits opposite to the direction of the planet's rotation. Nearly all retrograde moons are captured irregulars, their backward orbits a signature of the capture process. Triton is the largest retrograde moon in the solar system and the only large moon in the solar system with a retrograde orbit, because retrograde orbits are inherently unstable over geological timescales. Tidal friction is slowly lowering Triton's orbit. In roughly 3.6 billion years, it will cross Neptune's Roche limit and be torn apart, likely producing a ring system comparable in scale to Saturn's. Binary moon system. A binary moon system consists of two bodies of comparable size orbiting a common center of mass. Pluto and Charon are the best-known example. Charon's diameter is more than half of Pluto's, and the barycenter of their mutual orbit lies outside Pluto's surface entirely. Each body keeps the same face toward the other at all times, a configuration called doubly synchronous rotation. Whether Charon qualifies as a moon or as a co-dwarf planet depends on the definition applied. The system formed from a giant impact analogous to the one that produced Earth's moon. Submoon. A submoon is a moon in a stable orbit around another moon. None have been confirmed. The conditions for stability are narrow. The submoon's orbit must be small enough that the parent planet's tidal forces do not strip it away, but large enough that the host moon's own gravity can retain it. Theoretical analysis suggests that large irregular moons in wide, stable orbits are the most plausible candidates. No solar system mission has yet searched for submoons directly. Their existence remains a prediction of orbital mechanics waiting for observational confirmation. Thanks for watching. Which moon system should we cover next in detail? Jupiter, Saturn, Neptune? Let me know in the comments down below. Also, please remember to like and subscribe if you enjoyed this video.